Spooky. Atoms, electrons, and other fundamental particles in the universe behave in very unusual ways, completely contrary to what we observe in everyday life. For example, an object can appear in two or more different locations simultaneously, or rotate in opposite directions at the same time. This phenomenon is called quantum superposition. They also have the ability to penetrate barriers that large objects in the macroscopic world cannot overcome. This is the phenomenon of quantum tunneling, where microscopic particles can pass through barriers that they theoretically shouldn't be able to overcome according to classical physics. The strangeness of fundamental particles goes even further than that. An astonishing consequence in quantum physics reveals that objects can mysteriously become interconnected. This means that whatever happens to one object will instantly affect the other, a phenomenon known as quantum entanglement. This always holds true, no matter how far apart the objects are. Mr. Stank does not agree with the concept of quantum entanglement, believing it to be a mysterious phenomenon that occurs over long distances. However, some suggest that an object could emit a particle or signal moving extremely fast, affecting another object and creating an instantaneous sensation. Previously, experiments had ruled out any doubts that such signals fell within the realm of classical physics. However, there remains the possibility that this factor could move faster than the speed of light. To explore this capability, researchers in Geneva, Switzerland, conducted an experiment using pairs of photons, the smallest packets of light. The signal is split and transmitted through converters provided by Swisscom, reaching two stations in two Swiss villages approximately 18 kilometers apart. The stations confirm that each photon pair remains entangled. By analyzing one photon, scientists can deduce the properties of the remaining photon. Regardless of the signal, moving from one block to another takes only 300 millionths of a second. For the measuring stations to accurately detect photons, the beneficial factor must travel at a speed 10,000 times faster than the speed of light. Mr. San not only disliked the concept of quantum entanglement, but he also asserted that signals cannot travel faster than light. Spooky. He highlighted an interesting point. Nature has the ability to produce phenomena that simultaneously appear in many different places. According to Ryson, in a certain sense, the events unfolding simultaneously at this moment seem to exist outside of space-time. That is not something you can comprehend within the ordinary bounds of space and time. This is a phenomenon that the entire scientific community is meticulously and thoroughly studying. This discovery overturns the fundamental theory of light. Scientists have recently determined a new upper limit for the photon's mass through indirect measurements. Photons are described as massless particles. The reason is that they travel through space-time at a fixed speed and cannot increase or decrease their velocity in a vacuum. The particle of light always moves at a constant speed. The constant speed of photons implies that they are massless, and there is currently no compelling evidence to refute this. However, a research team from the University of Science and Technology of Sichuan has now. The Chinese Academy of Sciences and Nanjing University have published conflicting research findings. That refers to photons with mass, and we can absolutely count them through indirect measurements. By analyzing data from fast radio bursts, extremely intense flashes of light in the universe. Unidentified objects found spanning vast expanses between galaxies. The team found that the separation time is directly proportional to the photon particle's mass. From the ratio calculations, they deduced that the lower mass limit of the photon is 9.52 times 10 to the minus 46 kilogram. The energy level is equivalent to 5.34 times 10 to the 10 electron volts, and the inverse of the square of the speed of light in a vacuum is c⁻². This is the first time the interaction between photons has produced a non-zero result in a plasma environment, the research team confirmed. Although this is an extremely tiny limit, the discovery that light has mass, even just a little, would profoundly impact how we interpret the universe around us, as well as the basic knowledge of inherent physics. Theory of special relativity in Maxwell, or even unravel the unsolved mysteries of the universe that humanity has yet to decipher. Astronomers confirm that this study also highlights the importance of high-precision radio telescopes in collecting consistent, high-quality data. They believe that thanks to technological advancements, humans will measure even more accurately while uncovering the potential influences of light particles on the universe around us. Here are the English translation options based on your preferences. A newly discovered object has shattered multiple records. Not only is it the brightest object ever observed, but it has also become the most luminous celestial body to date. Ravenous. Mass every day and is estimated to be 17 to 19 billion times larger than the Sun. Each year, it accumulates an additional 370 suns. GO 52943551 was discovered in data from 40 years ago, but because it was too bright, astronomers couldn't identify it as a quasar. The extreme environment in the accretion disk around the active black hole heated dust and gas, causing it to emit brilliant light. Additionally, any matter in the accretion disk that is not absorbed by the black hole is ejected toward the poles and expelled as jets of energy at nearly the speed of light. As a result, this quasar can shine brilliantly, even surpassing the combined brightness of billions of surrounding stars. But even so, GO 52943551 is still incredibly impressive. According to the research team's calculations, its diameter is approximately 7 light-years, equivalent to 45,000 times the distance from Earth to the Sun. Initially, GO 52943551 was discovered by the Smith-Sarton Sky Survey telescope in 1980, but it took scientists decades to confirm it was a quasar. Large-scale astronomical surveys collect such vast amounts of data that scientists are compelled to use machine learning models to accurately analyze and classify celestial objects. In fact, this star is so bright that predictive models suggest it lies quite close to Earth. The research team identified GO 52943551 as a supernova, type Ia, using the 2.3-meter telescope at the Siding Spring Observatory in Australia. Thank you, everyone, for watching this interesting video.